Hi everyone, let's continue regression and using Jamovi. Here is linear regression. I'm going to use linear regression. But before starting this, first of all, we are going to upload a file. And same analysis we are going to perform over here, right? There is the one data set I'm having. And here is I'm going to explain you what is representing R, what R is representing, R is square, what is reflecting, and adjusted R is square, what it is reflecting. And here is, let me open a file. And my file is, that is browse and advertising. This is the my file name. And moment it will open, now we can see this is the sales column that is continuous variable, newspaper through advertisement through newspaper, and advertisement through radio and advertisement through TV channels. So we want to check sales influencing by which kind of advertisement. So here is linear regression. Sales is my dependent variable. Let me take first is TV. Covariate is TV. And now we can see model fit. There are two tables are here. Let me copy both these table and let me paste it both these tables over here. Then we will discuss. And I would explain you this Cook's distance also. This is my one of the table that is model fit measures. And another table that is model coefficient, right? This is the model coefficient. Let me copy this and let me paste it here. So these are my two tables. Model fit measures, it is actually R stands for that is correlation in between these two variables. So that means 0.90 means there is there is a positive high correlation between advertisement and TV, advertisement and sales. And R square that is reflecting, right? It means 0.81 means 81% variation in the dependent variable by independent variable. Independent variable, in this case, that is your sales means what we are saying, 81% variation in the sales due to television advertisement. So R square that is denoted. And model coefficient sales, now we can see television that is statistically significant because p-value that is less than 0.05. Then we come to the, if suppose we are taking radio as a factor. Let's say we are radio as a factor, but we cannot take it radio as a factor because that is, it should be a categorical variable. So model builder, right? And after that, reference levels, and we can come to the assumptions check. That's important. So first we are going to check normality test. And normality test, now we can see normality test. Shapiro will test that is 0.527. It means this data that is normally distributed because p value that is greater than 0.05. Not this one. Let me cross this. Delete this, and after that delete table, and let me go back. I want to take this table, normality table. I want to copy this and I want to paste here. And now we can see Shapiro will test that is p value that is less than, not less than 0.05. So we can say our data is normally distributed. So again, next is QQ plot, right? QQ plot, that is our data. You can see here, data is normally distributed. That is across the line. And further is model fit. Model fit, you can take F test also. And now F test that is reflecting, right? Yes, that is significant, means model is significant. And further is what we have to check, model coefficients, right? ANOVA also you can check. So this is there is the ANOVA table is also introduced, right? So TV that is also, we can say this one is the p value is less than 0.05. So I'm sure all these things you can report in your rest is you are going to save all those things. Predicted value, residual, Cook's distance. Yes, I was talking about Cook's distance, and let me when I click here Cook's distance, right? So let me explain you what is a moment. We will. This one is the Cook's distance. I can show you Cook's distance. And what is actually Cook's distance is explaining. Cook's distance, often denoted DI, is used in regression analysis to identify influential data points that may negatively affect your regression model. It will find out what points, what are they are reflecting, affecting your regression model. So in the next coming up video, we will discuss some more hierarchical regression analysis also, as well as I would explain you how you are going to interpret multicollinearity, how you're going to interpret autocorrelation, how we have to test it. So multiple regression, today I had covered only linear regression, means one dependent variable and only one independent variable. So in the next video, I'm going to cover up multiple regression. Thank you. Keep watching.